Consider the function f of x is e to the 2x minus 4e to the x. Determine the coordinates of the x-intercepts of f. You may wish to consider the factorized version of f. F of x is e to the x take away 4. So if we're after x-intercepts, e to the x take away 4 is equal to 0. Well, we know that e to the x is never 0, so we won't get anything from there. But from here we can have e to the x is equal to 4, which would mean that x is equal to the natural log of 4. So if that's the case, substitute back up to here. In actual fact, maybe we don't have to. The factorized form would be good. Oh, they're x-intercepts, so of course y is 0 anyway. So log 4, 0. Show there is only one turning point on the graph, which is located at ln 2, negative 4. Okay, so f dashed x would be 2e to the 2x, take away 4e to the x. And so for f dashed x to be equal to 0, we need 2e to the 2x, take away 4e to the x to be equal to 0, which means e to the 2x take away 2e to the x equals 0, which gives me e to the x take away 2 is equal to 0. And once again, we know that e to the x cannot be 0. And so that would give me e to the x equals 2, which gives me x equals ln 2 as required. And substitute that back in. So f of ln 2 would be equal to e to the 2 ln 2. Take away 4e to the ln 2. So put that in there. That would be e to the ln 4. Take away 4 times 2. E to the ln 2 is just 2. So that's 4 take away 8, which is negative 4, as required. Determine the coordinates of the points of inflection of f. So if we differentiate again, we get 4e to the 2x, take away 4e to the x, and we want f double dashed to be 0, which means that 4e to the 2x take away 4e to the x is equal to 0. And so e to the 2x take away e to the x equals 0. So e to the x take 1 is equal to 0. And of course we know once again that e to the x cannot be 0. And so we have e to the x equals 1, which means that x is 0. And if x is 0, so let's just go from this factorized form here. So f of 0 is going to be e to the 0 take away 4, which is 1 times negative 3, which is negative 3. So it's at 0, negative 3. Okay, finally, we want to sketch the function f on the axes below, labeling clearly all intercepts, the turning point, points of inflection. Some approximate values of the natural logarithmic function are provided in the table may be helpful. So we know that our f of x was e to the x, do it in factorized form. So it was that. So we worked out that the point of inflection was at 0, negative 3. So that's going to be our point of inflection just there. We know there was a turning point at ln2, -4. So ln2 is 0.7 according to this table. So about there. So that's ln2, -4. That's the turning point just there. The x-intercept was at ln4, 0, and ln4 is 1.4 according to this. So that's going to be about there. Okay, with no other turning points or points of inflection, really this bit has to go like that, fairly sharply up there. Now, as to what happens to the left, it might be handy to think about this in the form e to the 2x take away 4 e to the x. When x is negative, as x tends to negative infinity, both of those are going to tend to 0. Now, we know there's no other x-intercepts, so the only other thing that can happen here is for this to become an asymptote